Hello everyone, today we are going to talk about operators in Python. We are going to go over all the type of operators in Python. Actually, there are seven type of operators in Python. But what are operators? Operators are used to perform operations on variables and values in Python. So we could use operators together, and we could also, so the seven type of operators are arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. So we're going to go over those seven type of operators today. So let's start with arithmetical operators. So you can just go like so. Arithmetical operators go like this. Let's just say arithmetic operators like this. So the type of arithmetic operators are simply the basic arithmetic that we use in simple addition, subtraction, multiplication, division, modulus, exponential, and floor division. So if you say our here, we could have two variable here, x, say our x equals 4 and y equals 9. So the first one is addition. We could just simply say 0 equals x plus y. So we could simply print out our z. So we could check this out. We see here, adding 14 and 9 together, we get 3. So the second one could be minus. Could just come here and say and change our z value to y minus x. Then we could run this again, and we could say 5. Then we could go for division. We say that 2.5, right? Then there's something we call floor division here. That's just adding another sign of division to it, and you could say it actually eliminate the point there. We are not getting any float. We are not getting any float at all. So we could use simply multiplication here. You all know that should be 36. You can see it here. That's just multiplication. Then we can also use exponential. Exponential is just by adding another sign of this there. So now 9 exponential 4 should give us 6,561. So we could try and use modulus, which is going to divide it and return the remainder, which should be 1. So we can see it here. So those are just the type of arithmetic operators we have. So we could go over to, let's comment on this here. Sorry. We could go over to using, let's say, using assignment operators here. So assignment operators are just as like the name, we call it assignment, right? That's what that's just simply what assignment operators are. We could define a variable to x equals, say x equal 5. Then that should be okay for us now. Then here we want to add the value of, so this is the first assignment on the norms. Yeah, we just print out x here and we see it. We assign the value of 5 to x and printing out x here. So let's say we want to add something. We want our y to be x plus something. Instead of saying y equals to x plus 4, we could just say, sorry, let's say we want to change the value of x here to the current value of x plus 4. Instead of saying x equals to x plus 4, we could just simply say x plus equal 4. So this is actually the same thing as what I just finished saying. So if I should try this out, plus 4, which we all know is 9, we say 9 here. And this other operator here, can this make our code look kind of neater and shorter? You can say it's still 9. So the same thing applicable to subtraction. Then we go for division. You can see that multiplication, so modulus and floor division. Also for exponential to actually a way of assign almost all our operators to it. Almost all, we can use all the arithmetic operators with this and some other special operators which we're going to talk about here. So I changed my font size so you could see it more clearly. So when I talk about other assignment operators, the other assignment operators, just like, let me just put all of them in comment here before I go over them. So there are other assignment operators just like this, which we are going to go over. So we could start with this here, then so we are going to come back to this at the end of this lesson. So let's go to something we call comparison operators. So we also have comparison operators, which are used to compare between two variables of value. So we have them, and we have to at times, most time we use them with if statement. Most time we use them with if statement. So we can just have our x equals 5 and we have our y equals 10. So the first comparing operator, we can say, we can check if x and y is the same. Let's say if x, now just say z equals x equal 5, well, just like this. Then you can print out our z. So we can see here it's giving us false as an output because z is not, x is not equals to y. That's why it's giving us false here. But let's say our x happens to be 10. You can see it's giving us true here. So we can also check here by putting not at the front. This simply check if the x and y are not equal to each other. This should give us true because they are not equal to each other. Then we can check if x is greater than y. You can say that's false because x is actually less than y. And we can also check if x is less than y. You can see that's true here because x is actually less than y. Then we can check if x is less than equal to y. Less than or equal to, just like simple arithmetic. Is x less than or equal to y? Yes, x is actually less than y. So we can check if x is greater than or equal to y. So we can see it's false. But if you change this to 10, this x value to 10, you can see here is true. So the next type of operator we can talk about here is what I can call logical operators. So here we have logical operators, just like logical. So we have logical operators too. And logical operators are just like they are operators used to combine conditional statements together. So we actually have just three types of logical operator, which is and, or, and not. Just and like this, or and not. So we can also have something like this: x equals 4, y equals 7. So we can say our z equals x naught y. Actually, this we have to use if statement with it, or we could use it just like this by saying, let's say we want to check if x is less than, let's say we want to check if x is less than 4 or x is equals to 4. This should actually give us true. So when we print out our z here, you can say it's true because x is actually equals to 4. But if we check this, it's false because x is not less than 4 and x is never equals to 6. So this is simply way we can use or statement here. But if you want to use and, that means these two conditional statements have to be true for it to be true here. Just like our truth table, the and not. So we could check this. We could take this to 4. Sorry, we have not used our y variable. Let's use our y variable this time around. Let's use our y variable this time around. So we could take this to 7 and check here. Say this should give us true here because y false. Sorry, y is not less than. So we could check it like this. You can see it's true right here because y is actually less than 9 and y is equals to 7. I will also check like this if y is greater than or equals to 6. Can say it's true here because y is greater than or equals to 6. So you could go to the next type of operator. We are sorry, we've not used not. Shall not operator work in just a reverse way of this? So we just say like this, not can say it's false. Charlie, the former value was true, but now we are getting the opposite. So that's simply how not operation work. Operators work. So we could go to the next type of operator, which is identity. Identity operators. So identity operators are just like, so let's comment on this here. Identity operators. Oh, basically two here. So we have is and is not. So we can also have the same variable here, something like, so side place. Let's copy all this here. So when we copy all this here, we could just paste it down here, then uncomment them. So we could have this again and here, and we could just say we could check if x is y. We could check if x is y, and we could actually print out z. As you can see here, you can see x is not y. But if we say this x to 7, so she give us true. Yes, it's true because x is y. And right here we could check if x is not y. This should give us false because x is y right here. Then when we change this back to 4, we could say x is not y. So we move to membership operators here. So our membership operator work like this. Let's go membership. Just comment this down here. we all know what to mean by member. Just to these are just what we use to check whether they are a member of a list, a string, or all sorts of things like that. So go back here and comment. Sorry, that was too far. We could go back here and comment all this. When we comment all this, just like this, then we come down here. So let's check membership operators here. We actually two type of membership operators here. We have in, we have the in operator and we have the not in operator. So yeah, when we have our string, let's say we have our name equals, let's say Andrew. So for better, we might just want to convert this. For better work, we might just want to convert this name equals to all lowercase. Or I just write everything lower, but in case you're collecting it from the user here, so you can check it. So here we can check z equals. So you can say we want to check if a in name, want to check if that a is in name. So we might want to print out the answer of that. So we might want to read this up a little. So we can see here it's true because a is in name. But if we should change this to 6, false, because 6 is not in name. So here is false. So then we could check not into, just like this, not in. If C is not in name, print out here true because it's not actually in name. But if you turn this to D, see here is false. D is in name. That's why it's giving us false. Yeah. So, and the last but not the least operator today is pairwise operator. So talking about pairwise operator here, so we have bitwise operator. They are used to compare binary numbers. So that's how simply how bitwise operators. They're just like binary form of comparison. Not actually you have to use them to compare binary numbers. Just like binary form of comparison. So when we have our, so let's do this again here. Sorry. So we want to check now. We want to check these operators here. We want to check if x is less than 3 or x is greater than 2. So let's print out our z here. This is our first binary operator and this is an OR operator here. So when we print out our z, here, we could say it's true because one of these condition here is true, but actually here both of the condition is true. So we could change this to 7 because actually x is not greater than 7. But we can still say it's true. It's false. We can still say it's false. Sorry, I made a mistake. Actually, our x is false, so is our x is not less than 3, and our x is greater. So actually we could change this to something like 2 back, and we can say because one of these condition is true, so it's giving us true. But if we change this to and operator just like this, you could say this will be false because 2 of them are not true. The 2 operations have to be true for us to get a value of true here. So that's why it won't work that way. So also check like this. So we also check something like this here. Base x of value. Because one of these is true, you set the bit to true here. So when we check this to 7 here, see, this is false because none of them is true. So we also have one of these here. So let's use this. We have our negation here. See, the negation here is -1. Because we invert the bit, value of the bit here. Because if it do something like negation 3, you can say you are getting -4 here. So that's simply how operators work. So that will be all for today. Thank you very much for staying with us.